Okay, last lesson on sequences. And actually, I think I said that binomial expansion was our last lesson ever. But I think this is probably going to be the last one that you'll be doing. So this is, I should think, the last video for my year 13s at school. Okay, now this is now modeling questions. This basically brings together everything that we've done so far in sequences, mostly geometric and arithmetic. Those are the main things that you'll use in these modeling kinds of questions. And they're basically in real life context, so you need to set up what the sequence look like and then decide about how you're going to answer them. So anything involving compound changes like bank interest will form a geometric sequence as there is a constant ratio between the terms. We can therefore use formulae such as the sum to n to solve problems, but they're not always going to be geometric. It just happens that this first one here might be. I'm going to do one question from here. You can then maybe do the exercise, and then I'm going to do 4 exam questions afterwards. So this is probably going to be a long video, but you can pick and choose like which exam questions you actually want to go through, okay? So Bruce starts a new company. In year 1, his profits will be 20,000. He predicts that his profits to increase by £5,000 each year, so that his profits in year 2 are modelled to be 25,000 in year 3, 30,000, and so on. He predicts this will continue until he reaches annual profits of 100,000. He then models his annual profits to remain at 100,000. Calculate the profits for Bruce's business in the first 20 years. So the sequence is going to go something like this, where we have 20,000, then we have, what did it say, 25,000, then 30,000, etc. until we get to 100,000. And then after that, he just says that his annual profits are going to remain at 100,000. And so we need to try and work out how much he's going to make in the first 20 years. So I think what we need to do is find out how many years it takes him to get to 100,000, and then we can work out how many extra years that he's got afterwards. So our starting term is 20,000. It's an arithmetic, this one, actually, even though it says geometric here. I think it's going to come up later on. And the common difference each time is 5,000. And we want to find out in what year does he first make 100,000. So we're going to try and find out what is n equal to. Well, we know that un equals a plus n minus 1 d. If you don't remember that, you need to memorize it. So you get 100,000 equals 20,000 plus n minus 1 times 5,000. So 100,000 take away 20,000 is 80,000. We're going to divide that by 5,000, and that will be equal to n minus 1. 80 divided by 5 is 160 divided by 10, which is 16. So you get 16 equals n minus 1. So n equals 17. So this is the first 17 years, and that actually means that there are going to be 3 more years afterwards for the 18th, 19th, and 20th year where he just gets 100,000, okay? So after 17, it's going to stop. So what we now need to do is find out how much money he makes in these first 17 years, and then we're going to add on an extra 300k afterwards. So we're actually trying to add up the first 17 terms. Now, I prefer to use, in this case, because I know what the last one is, I'm going to do my formula, which is the sum to n is n over 2, first plus last, okay? You can just use that because we already know what the last one is. So we get 17 over 2, the first one is 20,000, and the last one is 100,000. So the sum up to the first 17 years is 120,000 times 17 divided by 2, which is, if I read that carefully, 1,020,000. So then the sum of the first 20 years will be the sum of the first 17 years plus 300,000, which is this extra £300,000 he makes in years 18, 19, and 20. So I'm just going to add 300,000 to that amount, and the total amount of money that he makes is £1,320,000. Notice how this one we needed to use the sum because it wanted to calculate the profits for his business in the first 20 years. So it's adding up all of those profits together. State one reason why this may not be a suitable model. I guess there's lots of different things. It could be that it is unlikely for profits to increase by a constant amount. Think of any business, they're not going to go up by the same amount each year. It is unlikely for profits to increase by a constant amount. Okay, now let's see what changes, because he's got a financial advisor. So Bruce's financial advisor says that the yearly profits are likely to increase by 5% per annum. Per annum just means per year. Using this model, calculate the profit for Bruce's business in the first 20 years. So there's none of this 100,000 is the limit. It's just every year it's going to go up by 5%. So that must mean that our starting term is still 20,000. I think that's still the case. It doesn't seem to be any different. It says in year one, his profits will be 20,000. The financial advisor is saying that each year it will increase by 5%. Well, how do you increase this by 5%? You multiply it by 1.05, okay? So you don't have to do them all manually. If you want to keep increasing by 1.5%, it's like compound interest from GCSE, you just multiply by 1.05. And we want to know how much he's going to make in the first 20 years. So we are trying to find out the total profit. Now the sum to n is a brackets 1 minus r to the n over 1 minus r. So I'm just going to put it all in the calculator. It is 20,000, 1 minus 1.05 to the 20, all over 1 minus 1.05. Okay, let's just type this in, see what the business, whether he's going to make more money this way. 20,000, 1 minus 1.05 to the 20, all divided by 1 minus 1.05. He makes, a little bit more conservatively, £661,319.08. Okay, so he makes a lot less this way because he's probably not going to be able to go up by £5,000 each year. Just want to see if that seems to be reasonable. 20,000 multiplied by 1.05 to the 19. Yeah, that seems like a much more reasonable amount. He's not going to be able to ever be earning that amount according to his manager, his financial advisor. Okay, so this one was arithmetic, this one is geometric because each time it is compounding, it's multiplied by 1.05. Should remind you of compound interest, where you would have the start amount and you multiply it by the multiplier, the percentage multiplier, which is 1.05. That does increasing by 5%. So if you want, you can have a go at exercise 3I now, but I'm going to go through and do 4 exam questions that are all new spec exam questions. Okay. So this one's quite short, it's only 5 marks, let's see what happens. It says there were 2,100 tonnes of wheat harvested on a farm in 2017. The mass of wheat harvested each subsequent year is expected to increase by 1.2%. So it's got this idea, it sounds similar to compound interest because it's increasing by 1.2% each year. Find the total mass of wheat expected to be harvested from 2017 to 2030 inclusive, giving your answer to 3 significant figures. So it's including 2017 and 2030. Now this reminds me of, what topic was it where we did this? You know when we were doing the sigma notation? Let's see if I can quickly get back to this. You can hear my laptop is dying at the moment. So I think, is it here? You know where we had the number on the top and the bottom and I said, oh, you might just be tempted to subtract them. I tell you what, I can't find it. I'm just going to go back to the question that we were on. You might be just tempted to subtract them, but that wouldn't be including the first one. So what you're going to have to do really carefully here is you're going to have to subtract the years. Where is it? Sorry about that. You're going to have to subtract them and then add on an extra year. And you can just think about it simply. If you were going to do 2017 to 2019, if you subtract them, you just get 2. But clearly you've got 2017, 2018, and 2019. So to find out the number of years, the first thing I'm going to do is I will do 2030, take away 2017, but I'm going to add that extra 1 on. So I always do it with like a smaller bracket, and then I work out what the pattern is. So 2030... take away 2,000, I can't believe I'm using my calculator for this, plus 1, so it's actually 14 years, okay, that's how many years this is going to be. So for part A of the question, we know that the starting amount of wheat was 2,100, the amount that it's going to compound by each year, it goes up by 1.2%, which is 1.012, this is 101.2% as a decimal, and the number of years is 14. So the total amount, that means adding all of those amounts together, so that's why we're doing a sum here, will be A, brackets, 1 minus r to the n all over 1 minus r. And we're just going to see what that comes up with on our calculator. And we get, it wants it to 3 significant figures. I'll write it out in full. But it wants this to 3 significant figures, so I'm going to go with 31800, and the units that they've been working in is tonnes. Okay. Each year it costs £5.15 pence per tonne to harvest for the first 2,000 tonnes of wheat, and £6.45 per tonne to harvest wheat in excess of 2,000 tonnes. Use this information to find the expected cost of harvesting the wheat from 2017 to 2030 inclusive, giving your answer to the nearest £1,000. Well, that sounds fun. Let's have a think about what this is going to be done then. So we need to find out how much wheat is going to be produced. Let's have a think. £5.15 for the first 2,000 tonnes, and then £6.45 for anything in excess of the 2,000 tonnes. So I wonder how we could do that. Well, each year, I can see what's going to happen here. Each year, they're already going to be doing 2,000 per year. So each year is producing at least 2,000 tonnes. So in 14 years, there will be 2,000 multiplied by 14 tonnes at £5.15. And then we can work out how many tonnes will be at the other part, okay? So 2,000, again, what am I doing using a calculator? That means that there is 28,000 tonnes, which are at the cheaper cost of £5.15. And let's multiply that by £5.15. You get that the cost of that bit is £144,200. Now, if 28,000 tonnes is going to be done, if 28,000 is being done at the cheaper price, we can work out how much is not at the cheaper price. So the wheat at £6.45, well, if there is 31,807, I've just rounded that, and we've already paid for 28,000, 31,807 minus 28, 1, 2, 3, minus 28,000. That means that there is 3,807 tonnes at that price. So I'll do 3,807 and I'll multiply it by £6.45 to find out what that is. So the cost of that is £24,555.15. So the total is going to be 144,200 plus £24,555.15, and they want it rounded to the nearest thousand. That doesn't matter if we didn't do the rounding very good earlier, but we did. So we get 168,755.15, so that's 168,000. So to the nearest thousand, £169,000. Let's see if we got that right. Great, £169,000 and 31,800. So that does round exactly how we wanted it. Okay, we've got 3 more questions to go. You might like to pause and try them yourself rather than just listening to me the whole time. Okay, we've got some more extraction minerals and things like that. So a company extracted 4,500 tonnes of a mineral from a mine during 2018. The mass of the mineral the company expects to extract in each year is modelled to decrease by 2% each year. So that means each year it will be 98% of what it was the previous year. Find the total mass of the mineral which the company expects to extract from 2018 to 2040 inclusive, giving your answer to 3 significant figures. So remember, we're going to do our 2040, we're going to subtract 2018, we're going to add on an extra 1 to take into account the first year. Okay, if you're not sure about that, listen back to what I said here. I talked about with 27 and 2019, I'd have to add on an extra 1. So if I do 2014, take away 2018, and I add 1, and that means that it is going to be 23 years of extracting. Okay, so for part A of the question, the starting value is 4,500. The common ratio is 0.98 because it's decreasing by 2% each year. If you multiply by 0.98, you decrease by 2%. And the number of years is 23. So the total mass which is going to be done is the sum of the first 23. So that is going to be A, brackets, 1 minus R to the power of n, all divided by 1 minus R, okay? So we have, if I put this in my calculator, 4,500, 1 minus 0.98 to the power of 23, all over 1 minus 0.98. So the total amount of mineral which is going to be expected to be extracted is, does it want it to anything? It wants it to 3 significant figures. So it's 83621.8 blah blah blah, and 3 significant figures, that's 83,600 tons. That's part A of the question. Find the mass of the mineral which the company expects to extract during 2040, giving your answer to 3 significant figures. So this one wanted the total mass. This one actually just wants you to find out how much mass is being extracted in that year. So we're actually trying to find out U of 23, not S of 23, but U of 23. What's the actual amount done in that year? Now, if you remember, UN is AR to the n minus 1. So this is going to be A multiplied by R to the 22, okay? So that's going to be 4,500 multiplied by 0.98 to the power of 22, and we get 2885.2 blah blah blah, and it wants it to 3 significant figures. So that's 2890, 2,890 tons, and that is this part that we've done here. So this is just like the previous question. The cost of the extracting the mineral each year is assumed to be £800 per tonne for the first 1,500 tonnes and £600 per tonne for any amount in excess of 1,500 tonnes. We need to try and find out how much it is in millions of pounds, okay, and it wants the millions of pounds to be to 3 significant figures. Well, it starts off by doing 4,500 and it finishes in the last year of 2,890. So every year it is going to be doing at least, each year it does at least 1,500 tons. So there are 23 years of 1,500 tons that cost £800. So this is going to be the cost of just doing the 1,500 tons in each year. So that's 23 times 1,500 times 800, which is 27,600,000 pounds, which we might just write as 27.6 million, okay? But then on top of that, it does some more, okay? So we know in total, it mines, the mining company mines, that is terrible, doesn't look like mines at all, 83,621.8 tons. In fact, I don't need to be that accurate at all. I'm just going to go with 83,622. Don't even need to be. And we know that there are 23 years of 1,500. So there are 34,500 at £800. which means that there are 83,622 minus 34,500 at the cheaper cost. So that's 83622 minus 34,500. That means that there are 49,122 tonnes at the £600 cost. So I will do 49,122 times 600, which is for 29,029.4732 million. I've just put the decimal point in. So the value of X together here, I'm going to find the total cost in millions, is going to be 27.6 plus 29.4732 and that gives me 57.0732 million, but it wants that to three significant figures, so it is just going to be 57.1 million. So X is equal to 57.1. Let's see if we got it right. Great, X is 57.1, 2,890 tonnes to three significant figures and 83,600 tonnes, just as we did. Okay, we are nearly there. We have just got question 6 and question 11. Okay, so if you're still with me, you're doing well. I have no idea what these boxes are, but we can ignore them. Okay, a small company which makes batteries for electric cars has a 10-year plan for growth. In year 1, it will make 2,600. In year 10, the company will aim to make 12,000 batteries. In order to calculate the number of batteries it will need to make each year from year 2 to year 9, the company considers two models, Model A and Model B. In Model A, the number of batteries made will increase by the same number each year. Using Model A, determine the number of batteries the company will make in year 2. Okay, this one I find kind of trippy, so I need to think about how many increments it's going to be doing, okay? So here is 1, 2, year 3, 4, 5, 6, 7, 8, 9, 10. And it is starting off making 2,600 and it's going to go all the way to 12,000 batteries. So the number of increments it's actually going to do is 1, 2, 3, 4, 5, 6, 7, 8, 9 increments. So to work that out of how much each increment is going to be, well, this overall increment from here to here is 12,000 minus 2,600. Which is 9,400. So the overall increment is 9,400, and there are 9 of these jumps going up. So the increment per year will be 9,400 divided by 9, which is £1,044.44. So the amount that it will make in year 2 will be 2,600 plus 1,044. Oh, you can't have it in pounds. What am I doing? Talking about in pounds. We're talking about batteries here. So you can't actually have it as, that will have it as 1,044 batteries to the nearest battery, okay? And when you add that to 2,600, you get 3,644 batteries. In Model B, the number of batteries will increase by the same percentage each year. Using Model B, determine the number of batteries the company will make in year 2. Give your answer to the nearest 10 batteries. So in this case, it is going to be going up. The increments are 9 increments. I guess we could do this in a formula kind of way. I guess I could have done this first one in a formula kind of way. We can see that A is 2,600. And this is U1, and then this is U10. We can see that U10 is 12,000. Maybe this would have been better for the first one. And we know that N is 10, and we're trying to find out what is R equal to. Well, we know that UN is AR to the N minus 1. So U10 is going to be equal to 2,600 multiplied by R to the 9. So that is 12,000 equals 2,600 times r to the 9. So I'm going to divide by the 2,600, and then I'm going to take the 9th root, or raise it to the power of a 9th. So that's 12,000 divided by 2,600. That is 60 over 13. That's equal to r to the 9. So r is equal to 60 over 13 to the power of a 9th. So the common ratio is 1.185225 blah 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 each year. So how much will it make in year 2? Well, in year 2, that is U2, that is just going to be A multiplied by R. So that is 2,600 multiplied by 1.18522 blah blah blah. I've already got that in my calculator. So if I multiply by 2,600, I get 3,081.5 blah blah blah, and it wants it to the nearest 10, so it is 3,080 batteries. I realise now I probably could have done that same technique for this first one that I've got here. I probably could have said that A is equal to 2,600. I could have said that N is equal to 10, and I wanted to find out what is the common difference. And I could have said that U10 is equal to 12,000, and it should have produced the same result that I've got here. I did mine in kind of a common sense kind of way, but that's probably the better way of thinking about it, like we did for this geometric one. Sam calculates the total number of batteries made from year 1 to year 10, inclusive of the two models. Calculate the difference between the two totals, giving your answer to the nearest 100. Okay, so for the arithmetic model, we know that A is 2,600. We know that the common difference was 1,044. And what else did we know? The number of years is 10. In fact, we even know what the last one is, so we can actually probably don't even need to use this thing at all. We can say that the sum to n is n over 2, first plus last. I'm sure you've come across that many times with me now. So n is 10, so that's 10 over 2. The first is 2,600 and the last is 12,000. We know that's the last already. So I've got 2,600 plus 12,000 multiplied by 5. Looks like they're making 73,000 batteries. Now the second model, which is model B, is the geometric. And for the geometric model, we know that A is 2,600 and we know that R is 1.1852. I'll just do 1.1852, I'm sure that's fine. And the number of years is 10. So this is our sum to 10. Our sum to 10 in this case is going to be A brackets 1 minus R to the power of n all over 1 minus R. Put it all in the calculator. 1.1852 to the power of 10, all divided by 1 minus 1.1852. And we get that is 62,741 batteries to the nearest battery, and he wants it to overall the difference to be to the nearest 100. So the difference is equal to the bigger one, which is 73,000. Take away 62,741, and we want it to the nearest 100. So we get 10,259, which is 10,300 batteries to the nearest 100. That was not an easy question. Let's have a look and see how we did though. Okay, so we got the 3,644 correct, we got the 3,080 correct, and we got the 10,300 correct as well. If you're still with me, very, very good. We have got one more question to do, which is from a past paper as well, so let's just see how this one goes. Okay, a competitor is running a 20-kilometre race. She runs each of the first 4 kilometres at a steady pace of 6 kilometres per minute. After the first 4 kilometres, she begins to slow down. So she goes 6, 6, 6, 6, and then after that she's going to slow down. In order to estimate her finishing time, the time that she will take to complete each subsequent kilometre is modelled to be 5% greater than the time she took to complete the previous kilometre. So using the model, show that her time to run the first 6 kilometers is estimated to be 36 minutes and 55 seconds. Okay, well, we actually don't even need to do anything with sequences. We could just say that the total time will just be 6 multiplied by 4 for those first 4 minutes that we've got there, plus 6 times 1.05, because that's 5 minutes greater than that one, plus 6 multiplied by 1.05 squared. So this is the first 4 minutes, the 5th minute, and the 6th minute, okay, because we've multiplied those bits like that. So that's 6 times 4 plus 6 times 1.05 plus 6 times 1.05 squared. It didn't say to do anything with sequences, so I can just go straight into my calculator. It comes up with 36.9, I've written it wrong, 36.915, but if you've got this button that does the commas and stuff, you can actually just press that and it will immediately tell you that this is 36 minutes and 55 seconds. Well, it says 54, but it rounds up to 55 seconds. Easy. Show that her estimated time in minutes for the rth kilometre for r being between 5 and 20 is this. Okay, well, we know, let's just say, if r is equal to 5, the amount of time it was going to take her was 6 times 1.05. For the 6th minute, sorry, not the 6th minute, the 6th kilometre, it would be the previous one, but it would get 5% longer, like compound interest. And for the 7th one, it would be another 5% longer. So all you really need to do here is just recognise that the power at the top is 4 less than the power at the top, is 4 less than the value of r. So if r was equal to, I don't know, n, it would be 6 times 1.05 to the power of n minus 4. Hence, time for rth kilometre is 6 times 1.05 to the r minus 4. There's no real other way of showing that other than actually just writing things out. So estimate the total time in minutes and seconds that she will take to complete the race. Well, how long is the race? The race is 20 kilometres. So the race is 20 kilometres. And we need to find something out about this, don't we? How much is... she runs the first 4 kilometres at a steady pace. So these are per kilometre. So we have got a 6, a 6, a 6, and a 6 minutes. And then after that, they're starting to change. They're going to be the 6 times 1.05, the 6 times 1.05 squared, etc. So this is the first 4 kilometres. And then there's going to be all of these for the remaining 16 kilometres, because there's 4 kilometres and 16 to make 20. So there's going to be 16 of these, and that will mean that the last one will be, this is, let's think, 16 of them, it will be 6 times 1.05 to the 16. Now you can either use the information that they've given here. I don't really like using that. I kind of prefer thinking about, okay, I'll deal with the first 4 kilometres, then I'll deal with the next 16. Because that's easy. That's going to take her 24 minutes. For this one, I can see that A is 6 times 1.05, R is 1.05, and the number of these things that there are 16, and I want to work out how long it's going to take, how long all these things are going to be added up. So it is going to be A brackets 1 minus R to the power of n, all divided by 1 minus R. And then we'll just add on the 24 minutes as well. So that's 6 times 1.05, 1 minus 1.05 to the power of 16, and 1 minus 1.05 on the denominator. And we get that this is 149.04219, blah, blah, blah. So the sum of all 20 will be the 24 minutes, plus the sum of those 16 that we've got there. I'm just going to add 24 on my calculator, which is 173.04. I'm going to press that little time button, that comma button, and that is going to change it into, what does it want it to be in minutes and seconds. Well, I've got it as 173 minutes and 2 seconds. I'm really hoping this is correct. £173 and 3 seconds. Oh, I don't think I've done a rounding properly. Let's have a quick look. Minus 173. Nope, I did the rounding wrong. I'm sorry. It should indeed say 3 seconds. The other way you can do this is you can take away the 173 and then multiply it by 60 to change it into seconds. 173 minutes and 3 seconds. Let's see if we've got it right. 36 minutes and 55 seconds. Just looking at the pattern. And then, yeah, this is actually the way that we did it. I think this formula is kind of useless. You come up with 173 minutes and 3 seconds. If you've made it to the end, huge congratulations. Well done, guys. I hope to speak to you soon. Okay, bye.